cross-site request forgery, aka CSRF. Let's dive into it and learn what CSRF is and how to protect our application against CSRF attacks. The formal definition from the OWASP.org states that CSRF is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. With a little help of social engineering, such as sending a link via email or chat, an attacker may trick the users of a web application into executing actions of the attacker's choosing. If a victim is a normal user, a successful CSRF attack can force the user to perform state-changing requests, like transferring funds, changing their email address, and so forth. If the victim is an administrative account, CSRF can compromise the entire web application. Okay, so that's pretty long text, but in a nutshell, a CSRF attack involves a request that was made on user's behalf without the user actually intending to make that request. It's a forged request where the user is tricked into making that request. There are multiple ways requests can be forged. For example, via man-in-the-middle attack, a JavaScript code being injected and then executed within the site via XSS vulnerability, a request that is made from another site where the hacker submits a request to the target website, and so on. So let's talk about how exactly a CSRF attack is constructed and how it works. As you know, when we make requests, the cookies are automatically transmitted via the header, which can also include the session cookies that could be used for authentication. Now, if the user is already authenticated and then the forged request is made, even if it's from another site, it can carry over the same session cookie, which lets the server know that the request is legit and the user is authenticated. Now let's look at this simple example. User logs into a website. It can be a bank, an expense tracker like the one that we're building, a social media, or whatever. It doesn't matter. User logs into some web application. The attacker then tries to trick the user into clicking a link that contains the malicious script. They do this by maybe sending an email, something like, hey, click on this awesome picture, or look, you won a new planet. Now, when the page is opened, the malicious script is executed. And remember that the attacker does not have to make a user perform any actions to execute the script. It can be a simple AJAX request that gets triggered as soon as the user opens the page. So what can we do and how can we mitigate and prevent CSRF attacks? A popular and a recommended method is to use a synchronizer token pattern, which we'll look into in this video. Basically, we generate a token on the server either for each request or per page load. Per request might be overkill and can be annoying when making AJAX requests, because then you have to first fetch the token from the server to be able to make that request. Instead, we could have the token be generated whenever the page initially loads, and then store that in a session and then use it on all the subsequent requests until the page again is reloaded, or maybe the token or the session expired or something like that. Such tokens need to be unique and unpredictable, and no MD5 is not a good option to generate these tokens. Then when we make the requests to the server, we need to attach the generated token to the request as part of the body. So we could have a hidden field within the form that will store the generated token, and then whenever the form is submitted, it's going to submit that token as part of the body. Another way we can transmit it is by using a custom HTTP request header whenever we make AJAX calls. We'll talk about that once we do some JavaScript. Then once we have the token attached to the request, the server needs to check and verify and validate that this token is actually a valid token. And we need to do that on requests that make some changes or maybe delete something or create something. So basically on post, put, delete, and patch requests and so on. Now you might be asking, what about the same site, secure, and HTTP only cookie options? Don't they prevent CSRF attacks? The answer is they help by a lot. As we discussed in one of the previous lessons where we talked about the session hijacking and fixation, session cookie options like same site, HTTP only, and secure basically prevent cookies to be sent cross-site. Secure is there to make sure that they are sent only if the connection is secure. HTTP only means no JavaScript access to the cookie, and same site is there for cross-site protection. That being said though, the CSRF token should still be used as an additional layer of security along with the secure HTTP only and same site cookie options, since they provide protection from the other attacks as well. There can be some edge cases, which is why having both layers of security is recommended. Also, most frameworks already come with the CSRF protection, and if not, there are plenty of open source libraries available that can be used, so you don't have to build it from scratch. Slim PHP has a first-party package for generating CSRF tokens and handling the CSRF protection with just a little bit of setup, which is what we're going to use in this lesson, and we'll go over its source codes to see how it actually works. So let's scroll up to the installation section, and we need to compose or require the Slim CSRF package. So let's open the terminal here, paste that in, and while this is installing, let's go back to the documentation to see how we can actually set this up. Seems like we need to register the CSRF key in our container so that we can reference it anywhere else within the code. So let's go back to the code. Let's close this out. We'll open the container bindings.php file, and in here we'll create a new section for CSRF, and we'll bind this to new guard. So it was Slim CSRF guard this way, and then we need to pass in the response factory interface object and some other arguments which we'll go over in a minute. Now the response factory interface, we already have that right here. So we can basically inject the response factory interface in our closure here and then pass that down. So we'll do response factory interface, response factory, and pass this in here. Let's import that, and this looks good enough. Let's inspect the guard class now and go over some of the arguments that can be passed to this constructor. The first one, as we already saw, is the response factory interface. Second one is the prefix, and we're going to keep this as the default. If you wanted to configure this, you could add a prefix entry within the app config file and then add a new property within the config class and then use that to pass to this constructor. The storage, we're also going to keep it as default, but you could pass your own storage if you wanted to. The default one will be the session, which works for us because we're using session-based authentication anyways. We're also able to pass the custom failure handler, but we're not going to do that for now. Maybe we'll do it later, but for now we'll just keep it with the default value. Then we have the storage limit and strength, and we're also going to keep these with their default values. The storage limit basically is there to remove older tokens from the storage, and it's useful if the tokens are generated per request. The strength is used for token generation logic, which we'll look at in a minute. The persistent token mode is something that we will pass as true instead of keeping it as default false. By default, a new token is generated for each request, and that is a good security measure, but as we discussed earlier, it can be annoying at times and is not needed for every use case. Instead, having a token persisted throughout the request per user session will be enough. So let's enable this from our container bindings, and we'll simply use named argument here to pass persistent token mode as true. Alright, so let's go back to the guard class and see how the token is generated. So let's scroll down here. We see this set storage method, which basically, if it's not given, it will use sessions. Then we have some more setter methods here, and we have this create token method, which creates the token. It uses random bytes function to generate pseudo random bytes, and then it converts it to hex using bin2hex function. Then we have the generate token method right here, which basically calls that create token method to generate the token, and it also generates the name of the token, which is used to store this token value within the storage, and in our case that storage is the session. So basically each time a new token is generated, it's stored as a new key within the session storage. Then we have this key pair property, which has two keys, the token name key and the token value key, and they're set to the actual values of the token name and the value of the token. Then let's scroll down and we have the validate token method, which basically validates and verifies that token using hash equals function. Again, it gets the token from the storage using the name. So this means that we need to store both name and the value in the front end somewhere, maybe within the form, so that they are submitted along with the post data. Now let's scroll down, and as you can see, the default token name key and the value keys are just the prefixed underscore name and underscore value. Let's scroll down to the process method, because this is what gets executed in the middleware. It's what actually verifies the token, because as you know, the guard class is the middleware class. We're binding it in the container bindings, and then we're going to add that as a middleware to our application. As you can see, it looks for the token name and value from the body of the request, and then basically checks the request method to make sure that it's one of these supported methods, which is post, put, delete, and patch. And if it is, then it validates the token. It has the logic for what to do if the persistence is enabled or disabled. It also handles the token regeneration when needed and calls the failure handler method if it fails to verify. If it's all good, then it continues processing the request while having the token appended to that request. And that's pretty much it. That's all it does. So let's close this out, and now we need to register this as a middleware. So let's open the middleware.php and we'll add it right here. So we'll do app add CSRF, and this should be good enough. We have added the CSRF protection to our application. Now, if we try to sign in, it should fail because we have not added any hidden input fields to actually pass the token value pairs so that this middleware could then validate and verify the token. So if we open the login page here and we try to sign in, we see that we get an error stating that it failed CSRF check. I'm not going to add any custom handlers for now. We might do that off the recording, or maybe you can try it as an exercise if you want to. The documentation actually has a pretty good start on how you can do that. You can pass this closure as the failure handler argument to the constructor, and within it simply set the CSRF status as false. And then maybe create another middleware that checks if the CSRF has passed or failed based on this attribute. And then if it failed, put your custom handling there. If it passed, simply continue processing the request. In case of failure, you can also maybe try to throw a validation exception, which will be handled by our validation exception handler middleware, and that way the user is redirected back to the login page with the form being pre-filled, and then you can show some error message or something like that. So give it a try and let me know if you have any questions. Alright, so now we need to add the fields in the front end so that we can actually submit the form and pass along the token name value pairs. If we scroll up within this documentation here, we see that we need to render these two HTML input hidden fields, with the name and value being set to the name and value keys of the token, and then the actual name and the value of the token. Now, if we keep scrolling a little bit more down here, we see that there is a section on how to access the token pair within the Twig templates. It is giving us an option to create a new Twig extension called CSRF extension, and it exposes this CSRF variable with the keys of name and value, and then the actual name and value of the CSRF token. And then we can add these inputs this way. I prefer a middleware solution instead of having a custom extension. So instead of this, we're going to create a new middleware. So let's go here and we'll create a new class called CSRF fields middleware. This needs to implement the middleware interface and provide the process method implementation. Let's close that out. And now within here, we can simply pass down the CSRF fields as global parameters to the Twig templates, the same way that we did within our validation errors middleware. So if we open the validation errors middleware, we can see that we're passing the errors to the Twig template this way. So we can do the same thing for the CSRF fields. So we're going to copy this constructor and put it here. We'll get rid of the session interface because we don't need that. And we'll copy this part and put it here. And we'll pass it down as a CSRF variable, which we'll create in a few seconds. Now let's go back to the documentation, and we can copy this section right here and paste it in here, and instead of returning, we'll just assign this to CSRF. Now we won't need this CSRF as a key here because we already have that right here. It's already being passed as the CSRF variable, so we can get rid of that. and simply keep keys and the name value. In fact, we can probably just take this and put it here instead of using variable. So let's get rid of that. And now we need to find a way to access the CSRF instance. Remember that we added this entry to our container bindings, so we need to get this from the container. We can do that by simply injecting the container interface as our dependency, and then we can do something like CSRF equals this container get CSRF, and let's remove this from here, and this should be good enough. Great, so I think we just need to register this middleware and then add the actual input fields. So let's open the middleware.php. We'll register it right here, add CSRF fields middleware class. Then let's open the login twig template, and we need to add these input fields in this form. We can copy the input fields from here because this is going to work the same way. We have access to the CSRF variable now because we're passing that down from our middleware. So let's add it right here, and this should work. Let's open the browser, go back to the login page, and we're getting an exception here stating that return value must be response interface. Oh, okay, I forgot to add the return here because we have the process method. It needs to return a response interface. We need to simply do return handler handle request, and this should be good enough. Let's refresh. That works. Let's inspect element here. And as you can see, we have two hidden fields, CSRF name, and this is the key where the actual token is stored in our session. And then we have the CSRF value, which is the actual CSRF token. Now, when we submit this form, these will be passed as part of the request. So let's fill in the form here. Let's hit login. We are successfully logged in, which means CSRF validation passed. If we inspect the login request here within the payload, we see that the CSRF name and the CSRF value are being passed. Now let's try to log out, and this failed the CSRF check because the logout is also a form request. It's a post request to the logout endpoint. So if we open the layout twig template, we see this logout form. So we need to add the same input fields in here. Now we could of course copy these two fields and paste it here, and this would work. But we would be repeating these two fields a lot throughout our application because we also have the register form, so which means we need to copy and paste it there as well. And I'm sure that we're going to have more forms down the road. And I don't want to kind of keep on repeating these two fields every single time. It would be better if we had something like CSRF fields or something like that, and then have this handle injecting the two hidden input fields. We can actually make this work. Let's go back to the CSRF fields middleware, and in addition to passing the CSRF keys name value, we can also pass fields here, and the fields can be HTML. We can use the here doc syntax, and we can call this CSRF fields and simply paste in that HTML here. So let's copy this and put it here, and we can replace the name to simply be CSRF name key, and the name of the value will be CSRF value key, and then the value of the name will be CSRF name and CSRF value. Now I know that it does not look good to have HTML within our application layer, but we could extract this into a helper class or something like that later. I just think that the convenience here is worth it. Maybe I'll take this and put it into its own variable somewhere here, fields equals this, and that way it looks a bit cleaner. And if we wanted to, we could extract this somewhere else. Now let's replace the fields on the login page as well, and let's also do the same thing in the register twig. So let's add it right here, and that should be good enough. Let's refresh the page in here. Let's click on this to log out, and we see some HTML here. The issue here is that the twig by default is escaping everything and is protecting us from XSS. We'll talk about the cross-site scripting in the next lesson, but for this we can disable the escaping because we know what HTML we are rendering, and we need this HTML to be rendered as a raw HTML. Twig has a filter that we can apply called row. So we can add a row here and do the same thing in our logout and login forms. Let's go here, refresh the page, and we see that HTML is not rendered anymore. Let's click logout. We see that the logout works. Let's try to sign up. Let's fill in the form here, hit register, and sure enough, that works as well. Awesome. So we've learned what CSRF is and how to protect it against it, and have used Slim's first-party package to implement the CSRF protection. In the next video, we'll talk about another security-related topic called cross-site scripting, as I mentioned before, also known as XSS. So thank you so much for watching. Pump the likes on this video and subscribe to the channel if you haven't already done so. I'll see you in the next one.